So for this lesson 7.1, we've got 5 important formulas to get us started here in our thinking of trigonometry. The first formula we're looking at is one that I'm sure you've seen before. It's the area of a triangle. It's 1/2 the base times the height. Now with triangles, the height has to be perpendicular measurement. And so we have various types of triangles, but whenever we are measuring and finding the height, it must be perpendicular to the base. So height and base. Here's base, but the perpendicular is not inside the triangle. We have to get the perpendicular over here. There's the 90. Next formula that you probably have seen before for triangles. All triangles have 3 angles. We'll call them A, B, and C. And it turns out that A plus B plus C is always going to add up to 180 degrees for every single triangle. Third formula to know about is the Pythagorean theorem, probably one of the most famous theorems in mathematics. It's been around for thousands and thousands of years. Now the Pythagorean theorem is about sides, and it must be a right triangle, which means it only works if we have a square corner and a 90 degree. And this side we call a leg, excuse me, a leg. And then this side we call the hypotenuse. And for a right triangle, a squared, the leg squared plus the other leg squared, will always equal the hypotenuse squared. So we have to be careful to get all of those sides and not mix up the hypotenuse, because the hypotenuse is always the one opposite the 90 degree corner. 2 more formulas. These you may not be familiar with. In fact, you probably, if you haven't studied trig before, you haven't seen them before. But there is a formula that will give us the angle in radians. It is the arc divided by the radius. Now, you have to beware that this angle only is in radians. So the formula is only giving us a radian value. Next, if we have a sector. Now a sector has this little, it's not a triangle because it has this extra curved piece on top of it. So it's got a rounded edge there, but it's like a slice of pizza or a piece of pie. And we have a formula for the area of a sector. Area equals 1/2 r squared times theta. So basically, it's a proportion of a whole circle area. Anyways, one other warning with this formula is theta will only work if theta is in radians. All right, so let's look at a couple of examples. You have these in your notes, but I separated them here to different slides. So if we're looking at an angle, and I rotate 90, okay, well that's not big enough. It's going to have to go past 90. 180 is going to have to go past that. Past 270, that would be 270 there. If I go all the way around, that's 360. That's too far. So 270 plus 35 more. So that's about like that. So this is my theta up here. It is 305 degrees around. So we're asked to find the area if the radius is 15. So imagine it is a pizza. And they cut the pizzas so that this is 15 inches. So that's a pretty big pizza. But just imagine that's a pizza. And actually, if I drew this, it would be a little smaller than that. Yeah, so, and we're eating this pizza. And so what is the area of what we're eating? Well, the sector would be all of this. It's not the whole circle. It's just that part of the circle. And we have a formula for it. Area equals 1/2 r squared times theta. So if we do 1/2, r is 15. Now the units, we have to keep track of the units. We're going to have 15 inches, and then we're going to be squaring that. And then we have to times it by theta. Now, in class, I would do a little experiment with you, but I would basically tell you that that's wrong. I am going to get the wrong answer here. And then I would try to get a discussion going and try to get you to think about why is it wrong. Maybe you can think about it right now, but it's right here. What do we know when we use this formula? That has to be radians. And 305 is not radians, it's in degrees. So this formula won't work like this. But I could change this into radians if I multiply it by the conversion unit that we were studying about earlier. Pi over 180 degrees. So the degrees cancel, and now I don't have degrees anymore. Now I have radians. And now I have a pretty massive multiplication to do. So if we start multiplying, I'm going to throw a 1 under here. And so we'll have to square that. And that's going to be 225. Oops, I want to use a different color here. We'll have 225. Now the units are inches squared. So 15 times 15 is 225, and inches times inches are inches squared. That's how we're going to measure our area. We have to times by 305, and we have to times by pi. And on the bottom, we have to times by 2 times 360. I'm sorry, I meant 180. So this is just a lot of calculator math. So we're just going to times 225 times 305 times pi, multiply all that, and then divide it by 360. And so in the end, so all that multiplication, I get this 215,000 number divided by 360. And when I finally divide that off, let's round it. And we will get approximately 599. I don't know, I just want to call that 600. And what are the units? The units are 600 inches squared. So if this is an inch, which it's proportionally not because that's 15, it would be a lot smaller, but it would take 600. If that was 1 inch squared, it would take 600 of these to fill in that pizza. So that is the area of the pizza that we ate. Let's look at another example. So we got to find the distance along an arc on the surface of the Earth that subtends a central angle of 7 minutes. This is something new. 7 minutes, so we'll be talking about that. And the radius of the Earth, we're going to say, is 3,960 miles. All right, so imagine we're looking at the Earth. And we've got a radius of the Earth. It's 3,960 miles. And we're going to walk. we're going to walk on, or drive or fly, more like fly maybe, but we're going to do an angle from the center. So if we start here and we move on this arc. So here's my arc, and I'm going to call that S. So I have subtended an angle that makes this arc. So the arc they're talking about is S. And the angle is a theta. And so our question is to find S. How far have we walked? Or how far around the edge of the earth have we flown? So we got to find S. And we've got to start thinking about some relationships. Now we know R. We have R. And theta, they told us was something new that we haven't quite studied yet, but we'll develop that here in a second. Theta is 7 minutes. So it's not time, it's an angle measure. We'll see that in a second. Okay, so I need an equation. Well, a few minutes ago, we did talk about theta equals S over R. So S equals R times theta. If I multiply R on both sides of that equation, now we just have one warning here. Our warning is theta. Theta must be radians if we're going to use this formula. Okay, so we have something that will help us find S. S equals R. 3,960 miles times theta. And we don't know what theta is yet. We know it's 7 minutes, but we got a few challenges to deal with. First challenge is, what's a minute? Okay, I'm going to deal with this. 7 minutes. Now, in things like astronomy and huge distances like the Earth, you can move a small distance, but it's expanded over 3,960 miles. So a tiny angle measurement does make a big difference. And so there is subdivisions of a 1 degree. We can subdivide a degree into a smaller unit of measure called a minute. So 1 minute is a fraction of a degree. In fact, there are 60 minutes in a degree. And if a person needs to go even further, there are 60 seconds in 1 minute. Now we're going to use these conversion ratios because we could make these equivalencies. 60 over a minute, 1 degree over 60 minutes, or 60 minutes over 1 degree. These are both 1. Now they're weird ones, but we can use those as conversion ratios to change. So I want to convert 7 minutes into degrees. Because if I have degrees, I know how to convert degrees into radians. So we can take 7 minutes, and which one of these ratios is going to make minutes go away and leave me degrees left? Well, that is the right ratio, because if I multiply by 1 degree over 60 minutes, the minute units will cancel. So I'm going to have 7 over 60 degrees. So it's a really small unit. It's a fraction of a degree, 7 out of 60. So the amount of rotation we've done on this angle is a fraction of 1 degree. So I'm going to take this guy and plug it into the formula, because at least now I know the angle. But it's still got one more problem, but that's going to be easy to fix. It's 7 degrees divided by 60, and the other problem is that it's in degrees. However, we know how to get rid of degrees. We can multiply this by pi over 180 degrees. And so just like we canceled minutes here to have degrees left, here we're going to take the degree units and cancel those out, and we're going to have a radian unit left. Now, the radian values, that's a little subtle here, but radian units are unitless numbers. So technically all that's left is the unit of miles. And now we just have a ton of calculator work to do. 3960 times 7 times pi over 60 times 180. And now it's just one giant, and these would be miles. And one giant calculation here. So in this next step here, I already multiplied it by pi. Now it's giving me, pi is an irrational number, so I have this long decimal that I'm just rounding off. And then we have to divide by 60 times 180 is that 10,800, and then do that division. We finally get about 8 miles. So it is something we could walk. If we walked an angle that was 7 minutes on the edge of the earth, it's like walking 8 miles. So of course my picture isn't to scale, but this is an example of using our formulas, S over R equals theta. And so we converted it into R, S equals R times theta. Anyways, there's some examples of using formulas in our trigonometry and integrating angles and converting angles into radians. All kinds of things are wrapped into this problem. Study hard with this, you guys, and good luck with it, and I'll see you in class.